We are still getting through differentiation or our differential calculus or calculus 1. We are still getting through, and here we are, differentiation of natural logarithm. Wow. You will love it. We are now getting to the interesting part of differentiation, and you will love it. Alright. So, before I take you through the differentiation of the natural logarithm, we have to go back and revise ourselves some more on our small algebra that we know already in algebra 1. Okay, so that it will aid you when we get to solve or take a differentiation of a certain function. As I always say, people don't fail differentiation because of fear, but because of how tedious the calculus is. It's not about how tedious the calculus is. They failed calculus 1 because of algebra. Alright, so now let's start. So let's first look at the graph of natural logarithm before we come back to the properties. So we know that this is the e raised to power of x, and this is what? Ln what? X. So let's see the difference between these two. Alright, so if you have e raised to the power x, this is how the graph will be. This is the nature of this what? Graph. But there is an asymptote here. I hope you can see the asymptote. There is an asymptote here. Alright, and when you have, let's look at the f of x. If you have ln x, it's also behaving like this, but there is also an asymptote here. So when we go to the properties, you can see that ln 1, you can take your calculator that when you press ln 1, you are going to get 0. I hope it's clear. If you have, let's say 1 is here, so only 1 will give you what? 0. But you try to punch ln 0 and see what you get. The graph gives us more sense about the properties. Ln 0 will give you masked error or undefined. The reason is that there is an asymptote here, so you cannot get a value for what? Ln what? 0. That is that. Okay, so the second property is about the product. It's about the product, and the product will be like this. That you know already. The quotient form to be like this, and the power form to be like this. So we are going to use this idea or this knowledge to simplify or expand some functions before we get in taking the dy dx, so that everything will be alright for you. Alright, so let's continue. So our first question is going to be, you have to simplify 1 ln 3x to the power 4 over 2y squared. Alright, we have to simplify this. So you see that this is in the quotient form, right? So what the first thing to do? The first thing to do is that you write ln of 3x over 4. Or we can see that minus ln of 2y squared. Alright, so we say this is a simplified form. You can end it here. Let's look at our second question. We are just getting through some small things fast. Okay, so 2 ln x squared plus 1, all these over square root of what? X. Alright, so having something like this, we can also see that this is in what? The quotient what? 4. So if this in the quotient form, then we can get something like ln x squared plus 1 minus ln square root of what? S. Then we can continue to say that here we can make this, or we can rewrite this as ln s squared plus ln 1 minus ln s to the power half. That is the root there. So here we can get, because of the power here, we can bring it here. 2 ln s plus, we know ln 1 is what? 0. So that place will go. Minus, the half will come here, we get half ln s. Alright. So we can get something to like this. Beautiful. I hope you can see that. Alright. So with this, you can factor the ln s out. Okay? You can choose to do it that way. There you go. But I just want you to end here. Alright. Let's go to the third one. Oh, okay. Let's look at this one. 2 over 3, 5 ln s plus half ln s squared plus 1 minus 4 s minus 2 to the power 4. Alright, so you are having something like this, and you can see that this is like in the expansion form, right? This is like in the expansion form. So let's try and combine this. Okay, so that it will come in a simplified, or let's say in a combination form. Alright, so now let's see how, like, we want to use our idea or our properties, whether we are moving from here to this side or from here to this side. Let's go. Alright, so now having something like these two, we can first focus the one in the what? In the bracket. So 2 over 3. And here, since we have a product here, alright, first of all, the 5 here means it's a power of this. So here is ln s to the power 5 plus 1 over 2. Sorry. And the 1 over 2 is also like the square root. So ln square root of s squared plus 1. Alright. Minus s minus 2 to the power 4. I hope you guys see that. Alright. So now, since we have 4 here, then we can go and multiply that by that. Then we get what? 16. Okay? Okay, let's continue. Now, having this 2 over 3 come out. Okay. So now we can see that plus is here. So we can apply the product idea here. That this will be ln square root of s squared plus 1. All this over ln s to the power 5 minus, oh sorry, it's a product. So ln s to the power 5. Okay, so now the argument is s to the power 5. We'll multiply this. So we are going to get something like s to the power 5 times s squared plus 1. Alright, something like this. Minus the ln of, is there a ln there? Oh, there should be a ln there. There is no 4 here, it's ln. Okay, so here is ln. Sorry, let's continue. So here we get s minus 2 to the power 4. Alright, let's continue. So now, since we have a minus here, we apply the what? The quotient. So 2 over 3, the same one here. Ln s to the power 5, square root of s squared plus 1. Alright, all these over ln minus 2 to the power what? 4. Don't end. You can still do something. Oh, sorry. You can still do something. 2 over 3. Ln is here, so we can combine these two. Because we can write, if we can write ln x over y, which is the same as ln y over ln x over ln y. Then we can write this in a combination form like ln x to the power 5 x squared plus 1. All this over x minus 2 to the power 4. Alright, so we can get something like this. And we know that this 2 over 3 at the back of the ln means it is being what? Wow, I hope you can see that. So we can end up getting something like ln x to the power 5 square root of x squared plus 1. All this over x minus 2 to the power 4. All to the power 2 over 3. Alright? So we can get something like this. It's beautiful. It's beautiful. Let me see if I can get something for you to go and try. Alright. I tried bringing you this question to go and try, but we have solved it together, okay? So now let's see how we can go through so that you go and solve this one. Okay, so with this, we know that the linear is applying to the numerator and the what? The denominator. So we can split this as this, and you will agree with me like to that. Alright, so with this, you can see there is a product here. So here too, we can split it by bringing the plus there. And with this side, we can change the cubic root to 1 over what? 3. Alright, so the power will come here. This one too is a power. It will also come here. And this one too is a power. It will also come here. So from here, you can choose to still continue with it if you want to do right. 5 ln x plus 2 ln sine 5 over x minus 1 over 3 ln of x to the power 4, right? Plus ln of, but don't forget that this 1 over 3 will affect it. Ln of what? 2. You can even still continue again by bringing the power here. It depends on you. Alright, so you go and expand and simplify this for me, and we will be back for the differentiation part. Bye bye.